Hello everyone, Ewan from Elixir Experts here. Today I'm going to discuss potential issues using the time impact method of delay analysis in dispute resolution and why it is potentially used by some parties. As demonstrated in my first video showing the time impact method in action, it might prove unreliable in dispute resolution if it does not accurately forecast the actual effect of a delay event. This is because the forecast of the likely effect of a delay event on completion may turn out to be inconsistent with what actually happened, and the method does not consider subsequent project progress of what actually happened. If subsequent progress is inconsistent with the findings of the analysis, it raises questions over its reliability in dispute resolution, and it's my experience that tribunals prefer evidence that relates to what actually happened. An extension of this is when a party exaggerates the duration of a delay event to give the impression that it had a more significant impact than it actually did. This can mean completion either appears to be delayed more than it possibly should have been, or make a delay event appear as critical to completion when another delay event was actually critical. Next, if the program is only updated at monthly intervals rather than at the time just before a delay event occurred, then there may be inaccuracies arising from not updating the program in the period between the delay event first arising and the date of, say, the monthly update. This can mean that the delay event might not have been critical or had the effect claimed. Ideally, any progress in the intervening period needs to be accounted for to show the true status of the works at the time of the analysis. The method can work well where there are a limited number of delay events, but equally, if there are a significant number of delay events being modelled, it can lead to the method becoming complex, confusing, and potentially costly to implement. An analysis using this method may only consider selected delay events, which may in turn favour the party performing the analysis, if, for example, the analysis ignores other culpable delays. In other words, the results of such an analysis might be biased and unreliable. The baseline program upon which the analysis is formed needs to be realistic and capable of achievement in terms of being properly logic linked with accurate activity durations and progress recorded accurately immediately prior to a delay event arising. In addition, program updates need to be realistic and capable of achievement. For example, if the program has been altered to reflect mitigation or acceleration measures, these need to be considered carefully, as otherwise they can conceal or distort the impact of delay events on the project. The time impact method of delay analysis requires regular program updates, which may or may not always be available. Therefore, it can be said to be quite data hungry. The program updates also need to be regular, accurate, and at sufficiently close intervals to model the true effect of a delay event on these programs. A practical issue using this method can be where there are, say, 30 program updates and any necessary required corrections may need to be made in all programs. So why do parties use this method of delay analysis? Well, firstly, it's recognised in the Society of Construction Law's Delay and Disruption Protocols, 2nd edition, February 2017, as a legitimate method of analysis. Indeed, there are 6 methods of delay analysis recognised in the protocol with arguably equal billing. However, since the time impact analysis method does not capture the actual delay caused and instead relies upon forecasts of the delay as discussed earlier, it is not always reliable in dispute resolution. Secondly, it could be mandated by the contract as the method for assessing delay. Indeed, the NEC form contract assesses delay akin to a time impact method of analysis, so it is always prudent to check the contract for any contract requirements for assessing delay. During the currency of the project, it is a fair way to assess extensions of time, as work remains outstanding and the contractor needs to know whether it is entitled to an extension of time to the time for completion in order to plan its works efficiently. Indeed, it is not too dissimilar to the contractor needing to know the time for completion at the outset of a project. If the forecast is correct, the program is accurate and the delay is modelled accurately, then this method can be reliable in dispute resolution. Next, it can give answers beneficial to one party, which may suit a party trying to maximise its commercial position by being selective about delay events or exaggerating durations of delay events, as discussed earlier. It should, however, address progress and so should reflect the actual or contemporaneous critical path if performed correctly. It can also be developed from good site and contract management practice relatively easily. Indeed, if a contractor has followed the program requirements of, say, the NEC form of contract and submitted programs on a monthly basis, then these should show delays arising on site as the project proceeds. This information can then be utilised in any formal analysis. Finally, the analysis can be made more robust by verifying the results against known as-built events to check that it is consistent with as-built progress. Indeed, as I referred to earlier, if the forecast is correct, the program is accurate and the delay is modelled accurately, then this method can be reliable in dispute resolution. However, it is my experience that tribunals prefer evidence that relates to what actually happened rather than relying on forecasts or hypothetical delays. That's it for now. Have a great day.